All right, now we're going to talk about number 28, which is right here. And it is different from number 27. And the way that it's different is that you could see in number 27, okay, that you have this absolute value part, okay, and you have it being multiplied on the outside of the absolute value by a constant, by a number. That is going to have a different sort of thing to it than if you had an absolute value piece right here. And then instead of a constant, you actually have a function being multiplied, or in this case, you can think of it as divided by the absolute value piece. And so it's slightly similar, but there is a huge difference in what happens in this case. So I'm going to go ahead and turn to the next page so that we can start working out this situation. Again, we have to find basically everything there is to know about this function. And so we begin with analyzing this function by trying to graph it. Now, to graph this function, one can begin by seeing, how it works out when you have y equals x plus 4, like without the absolute values. Okay. Y equals x plus 4 over x plus 4. And as you know very well, you can kind of think that, okay, these things cancel. But they only cancel, the numerator and the denominator cancel. They kind of turn into 1, okay? And I'm saying kind of because that only works as long as the denominator is not 0. So you have to be careful about setting this equal to 1. You can't just cancel away. You have to say, well, it equals 1 as long as the denominator is not 0. Now, when is the denominator 0? It's 0 when x plus 4 equals 0, and that means when x equals negative 4, so you don't want it to equal negative 4. And whenever the x values are not negative 4, then this function is kind of looking like 1, the constant 1. So if we were to kind of graph what was going on here, okay, which I'm going to put here in green for now, okay, what we would get is looking like a 1 constant. Okay, so I'm going to just go ahead and that's where 1 is. Okay, and you can see that this is where, okay, you have your y-intercept, you have no x-intercepts, okay, so the y-intercept's at 1, no x-intercepts, and so far, when you're doing the constant function, okay, what happens at x equal negative 4? What are we going to do about that part? Well, if we go, so here's x equal to negative 4 down here. Whoops, excusey. That's there, okay? So that's negative 4. Okay, and so what happens right here? Well, as you can see, all right, the function y equals 1 only is valid when x is not negative 4. Otherwise, it's undefined because then the denominator would be 0. So what would happen here, oops, I didn't want that to be that big. Let's get a little piece away, is you get a hole like that. That's where these little holes are introduced. So you have it undefined at negative 4. And this is really what this function here looks like. Okay, but this is not f of x being absolute value of x plus 4 over x plus 4. This is just regular without it. The thing is that we have to really understand what's happening here. Whoops, excuse me. We gotta. I think it's best to look at it algebraically, okay, and to remember what the absolute value actually is as a function. Okay, so I'm going to give myself some space here, and I'm going to rewrite here absolute value of x plus 4. what that is it is going to have two possibilities. It's either straight up x plus 4 when x is bigger than or equal to -4, right? Or it's negative x plus 4. Okay, this is the definition of absolute value when x is less than -4. Okay, so that's just the key to understanding all absolute values. I could have kind of stuck in whatever is going on here. If I had absolute value, say, of a star, then what is that? Well, it's going to be straight up star as long as star is positive, and it's going to be negative star as long as star is negative, because a negative of a negative is positive, and that's why you get the absolute values. So this is so that's what's happening here. I'm just rewriting it in terms of as this piecewise function. Now what happens when we take this function? I'm going to throw in divide by x plus 4. So let me give myself some space here. I should have done a little better job. Let me zoom in, excuse it, and I'm going to move things around so we can give ourselves some space. All right, and I wanted to, okay, let's do that. There we go. Now what I wanted to do, I'm going to zoom back out. Okay, whoops, that's too far out. Okay, is to go in here and, like I said, divide everything. Oops, get my green pen. I wanted to divide, everything in this absolute value by x plus 4 again. So go in here, to finish off this problem, we're going to divide by x plus 4. So everything gets divide by x plus 4, divide by x plus 4. Okay, the domain piece right here, this doesn't change, notice. Okay, that just stays the same. And now what we can do is, let's go back over here. What we can do is kind of go back to this discussion right here and simplify each one of these expressions, and you could see, that I'm going to rewrite this now in black. Okay, is that x plus 4 absolute value over x plus 4 without the absolute value is going to be, well, what is this piece right here going to be? Well, that's just 1, okay, as long as x is not -4. Okay, so it's going to be 1, okay, but it's going to be 1 where x is bigger than -4. And then now we're going to figure out this bottom piece, and what's that going to be? And that equals -1, okay, yes, -1 as long as x is less than -4. Okay, and so this is the final result of our graph, and you can see what happens here in our actual graph. Okay, let me pick different highlighter colors again. Okay, so you're going to have this piece happening for this domain. That's here. Okay, that's the domain. So this is the part of the function that we're going to maintain. It's going to be maintained at 1. Okay, but now what happens is that we now have this second part of the domain, and this is going to be the function at y equals -1. So let me get my green pen here. So at -1, which is down here, Okay, and when x is less than -4, that's this piece right here of the domain. So we're going to be at the value -1. So I'm just going to, I should use this green pen right here. So we're going to continue our graph. I ran out of space. Let me move the paper over here. Okay, zoom out a little bit. Alrighty. So we have -1 that way. And we have this little open piece. So let me erase the original piece. Oops, whoa, got too carried away there. I'm going to erase a piece of that negative we don't need. And so that's going to get rid of that. And so this right here is the final result right here. Okay, so our graph is going to be this, and then here, and where the switch is going to happen at x equals -4. So once you have the graph, you should be able to talk about all the other things about the function. Like, as we said, we have, y-intercepts are here. There's a y-intercept there. There are no zeros of this function. The domain is everything but -4. So these are things that we can write down. Okay, so let me start by writing some of these things down over here. Let's see. Domain, as we determined earlier, everything but -4. Yeah. The range, how high and how low does it go? It goes as high as, and actually just only at 1, and it also hits -1, but it hits nothing in between. Okay, no values of y in between. And let's see. So you have an x-intercept. Are there any? And you can see that there's none. Okay, so I'll put none. And what about y-intercepts? Are there any? And there is, and that happens at y equals 1. Okay. And are there the increase or decrease? No increase, no decrease, but it is constant on the interval -4 to infinity and -infinity to -4. So you have constant pieces of it, and this is pretty much everything there is to know about this function here. Okay, I hope that wasn't confusing, and if you have any more questions, just let me know.